Hello everybody, this is Unit 2, Day 4, making our way up to circles, all right? So we're still talking about area and perimeter, but in this case, all right, if you notice that it doesn't say perimeter here, it says circumference, okay? So what you got to think is this. Circumference is just a fancy word for saying perimeter of the circle, all right? And so when we get down to definitions, I'll explain that part further, all right? But in order to find the area and circumference of a circle, we first have to talk about what a radius and diameter is. So let me see if I can get a nice circle in here for us. Perfect. Scroll in here. Get another nice circle down here. And beautiful. Okay. So this is what a radius is. So the radius starts at the center of your circle and goes out to the edge. Goes out to the outer edge of your circle, right? And so this measure is equidistant all the way around your circle, right? There's not a point. I mean, if it's a true circle, which I'm saying it is, right? Every one of these distances, right? So if this distance was 5, well, then this distance would be 5. And then, if there's another radius here, well, this distance would be 5, okay? And so the radius is just the distance from the outside of the circle to the direct center of the circle, okay? So that's what a radius is. Diameter, all right, looks like this. So it goes from one edge, goes through the center, and then goes directly to the other side, a nice straight line. Actually, that doesn't look that straight. Try it again. There we go. Okay, nice straight line. Now this one measures from one length of the circle to the other, and if this length was 5 here, right, if we're comparing from our last circle, well then this length would be 5, and so the diameter, all right, is actually equal to twice the radius. Okay, so your radius is equal to 1/2 of your diameter. Okay, or your diameter you can think of as twice as your radius. Okay, but the radius is half. All right, so that's the difference between both of those. So you'll see those things kind of get intermixed throughout the unit and throughout different problems as we go through this year. And so just be aware that your radius is different than your diameter. Okay, pi. Well, pi is just the 3.14159.265. Normally we just more or less focus on the 3.14, right? But in your calculator, when we, actually I probably should grab my calculator because I know I'm going to use it. Your calculator, underneath your clear button, you want to hit second, and then right above, or right below your clear button, and there's this little button right here with an arrow, and right above it is that little pi symbol, so you'll have to hit second and then that button right there in order to, if you want a more accurate answer when using the numerical value of pi, then use the one on the calculator. All right, 3.14 only has 2 decimal places, so if you want a more accurate answer, obviously you use more decimals. Anyway, that's pi, right? And you see it represented like this. Okay, and then formula for the area of a circle is as follows. So area is equal to pi r squared. Okay, that's the area for a circle. All right, and again, we're still finding those one by one boxes. All right, inside the shape. Remember, area is the numerical value inside the shape. Right, so inside the circle. All right, and then the formula for the perimeter of a circle, or the circumference. Okay. We don't call it perimeter, we call it circumference, but think of it as the perimeter, right? It's the distance around the circle. Well, that is just C is equal to either 2 pi r, or you can also see it written like this, the diameter times pi, okay? And the reason why both of those work is because, well, the radius is half the diameter. So if they give you the diameter, instead of multiplying radius by 2, you just multiply the diameter by the numerical value of pi. Okay, so these are our formulas. All right. And so now let's actually put some numbers in here and get talking about these things. Also, it's important to point out, a lot of people are like, where does this number pi come from? Pi is actually the numerical value you get when you divide the circumference of a circle by its diameter. Okay? And what happens is you'll always get that number, which is pretty cool. All right? Not sure exactly how they discovered that number, but a long, long time ago they found that you take the circumference of a circle, divide it by the diameter, and you get this numerical value. All right? So a long, long time ago is when they came up with this value of pi, and that's where it actually comes from. Because if you look at our equation down here, right, c is equal to pi times the diameter. Well, divide by d, and you get pi is equal to c over d. Okay? So if you're ever wondering where they kind of came up with that number, it's because a long time ago they discovered that the circumference of the circle divided by the diameter is always this long decimal number. So they finally gave it a name. All right, so the circumference. Okay, so find the circumference of a circle whose radius is 4. All right, so here's our circle. There's our radius, and the radius is 4. All right, so in order to find the circumference, I go 2 times pi times the radius, which is 4. So you get 8 pi, which is 25.132.74123 units. Oh, sorry, they gave us some, not units. They gave us some unit measure here. It's actually feet, okay? And so that is our answer. Now, it wasn't specific on your decimal place there, so anytime they don't say anything about what kind of decimal place they want you to round to, you have to write out all the digits. Okay, sorry about that, guys. All right, find the circumference of a circle whose radius is 7. Okay, here's a nice circle. Here's our radius. This is equal to 7. So c is equal to 2 pi times 7, which is 14 pi, which is 43.982.297.15, and this one is in centimeters. Okay, not centimeters squared. Okay, it's because we're finding the distance around the circle, not inside. All right, if a circle has a radius of 6, what is the circumference rounded to the nearest whole number? Okay, cool. They told us to round. Nice. Okay, so here's our circle. Here's our radius. So c is equal to 2 pi times 6. It's equal to 12 pi, which is equal to 37.6991184, and this is inches. Oh, we got to round up. Okay, so the nearest whole number, 38 inches. Cool. I like that number a lot better. All right, let's keep going. Oh, this one, okay? They gave us the diameter. All right, well, the diameter is 1/2 of your radius. Or, I'm sorry, your diameter is twice your radius. Radius is 1/2 your diameter. So, in this case here, all I need to do is I go pi times the diameter, which in this case is 20. So you get 20 pi, which is equal to 62.83185307 centimeters. Okay? And that is how you find the distance around the circle, or better known as its circumference. Okay? Let's go down to area. So find the area. We'll just skip the circumference part, okay? So just find the area of the circle in terms of pi. Okay? So area is equal to pi r squared, all right? Which means I'm going to take 40, chop it in two, okay? So we get 20 squared, which is 400 pi, which is 1256.63061. Oh, we don't have any, so it's just going to be units squared. Okay, because we don't have any terms of measurement there, so we just put units squared, or 1,256.63 square units inside our circle. Okay, talking about these guys right here. All right, so anyway, let's go on to the next one. Find the area of a circle with a diameter of 54. Okay, again, you got to take 54, divide it by 2, so you get 27. And so find the area of a circle. So we're going to go area is equal to pi 27 squared. And I think that's 729, but I could be wrong. Nope. All right, so we get 729 pi is equal to 2290.221044. And they gave us decimeters. So decimeters squared. Okay, keep going. Radius of a circle. Okay, so our radius now, back to just halfway across, right? So radius is 5, find the area. Area is equal to pi times 5 squared, which is 25 pi, which is equal to 78.53981634 inches square. Okay, keep going. Was the area of a circle whose diameter, okay, so in this problem right here, they're giving us the diameter. All right, and so our diameter is 14, so our radius 7, so area equals pi 7 squared, it's 49 pi, which is 153.93804 centimeters squared. Okay, down to the end here. All right, so what's a math problem without adding some words there, right? Okay, eventually that's what it comes down to. So let's put some real life scenarios on these guys, right? So a designer needs to create a perfectly circular necklace, okay? So he wants to create a nice circle necklace, okay? We'll put a little diamond down there at the end, okay? There we go. There's our little necklace. All right. So the necklaces each need to have a radius of 10 centimeters, which means that that distance right there from the middle to the outside needs to be 10. Remember, we're talking radius. Okay, so what is the largest number of necklaces that can be made from 1,000 centimeters of wire? So the goal of this problem is they have 1,000 centimeters of wire, and they want to know how many necklaces I can make with a radius of 10. Okay, so first we need to figure out, all right, what is the distance, right? What is the measurement of this necklace with a radius of 10? And I'm talking about the outside. So this is a circumference problem, right? Because we don't care about the inside of the necklace there, right? We don't want to fill that part in because that's where your head goes, all right? So we're worried about the outside, all right? So, so C is equal to 2 pi times 10, which is equal to 20 pi, which is equal to 62.83185307, and that is centimeters. So that is our length around the necklace, right? Our circumference. So now we know that it takes 62.83185307 centimeters of wire to create a necklace that'll go, that'll have a radius of 10, right? So, so now we need to see how many of these we can make. So in order to find that, I take 1,000 and I divide it by that 62.8318. Okay? So by doing so, I get 15.91549431. Okay? Now, here's the $1 million prize here, right? That's how many necklaces I can make. 15 necklaces, okay? But let's think about this. Can I make 0.914 of a necklace? No. Okay, so when you have a problem like this, when it involves actual real things in the world, okay, we need to take into account, all right, well, we can't make 16, but we can certainly make at least 15 necklaces. So our answer is 15 necklaces. Okay? All right, last problem. A dog is tied with a rope to a stake on the ground. The length of the rope is 5 yards. What is the area in square yards in which the dog can roam? Okay, so here's our dog leash, right? Let me draw my awesome dog picture, okay? Right, there's the pup. Okay? So, they want to know what kind of range this dog has, right? How far can he walk around, right? What's his distance, his square, what is the area that he can roam? Okay, so we're looking for the inside now, all right? We're not worried about what's the distance he can walk around. I want to talk about the square yards, and that's the key here, guys, is where it says square yards, right? Remember, when we're finding circumference, we would just be talking about yards, right? The distance around the circle, right? We want to know how much room does this guy got. So in order to find that, area equals pi r squared. In this case, our radius, is 5. So we get 25 pi, which I feel like we just found that. 78.53981634. Okay, and it's going to be yards squared. Okay? All right. So, for homework, I want you guys to try all 6 of those problems. Okay? Any questions, bring them to class, and good luck.